Let me welcome you to the 44th lecture of NPTEL online certification course Drilling and Blasting Technology. So, we were discussing the different tutorials after we have completed the basics of drilling and blasting technology, different designing of the drilling and blasting system, then the performance, how those performance are calculated for the blasting and drilling, then the designing problems, allocations of the machines we have already covered, and now for last couple of lectures we are considering the how to calculate the cost for different drilling operations and blasting operations. Particularly in the last class we have covered the different cost heads and how to calculate those cost heads in terms of capital cost, maintenance cost, in terms of operating cost, in their subcomponents also how to calculate interest, depreciation, then how to calculate fuel cost, how to calculate consumables, all these are discussed. Last lecture we have completed the tutorial related to the cost analysis of drilling operations in surface bench blasting. In this lecture we will do another tutorial for cost calculations in underground blasting. So, the problem is you consider a twin boom jumbo. What is twin boom jumbo we will see in the next slide. That is engaged in a drive of 4 meter by 5 meter. Okay. So, this 4 meter by 5 meter is the drive size and a 4 square band cut. We have already given you the design, how to design a 4 square band cut in our previous lecture. So, a 4 square band cut design is practiced. 4 square band cut means where we provide a centrally reamer hole, then we place the blast holes in a form of square around this, then the square is gradually expanded and by this way 4 squares are made. So, this is first square, this is first square, this is second square, this is third square, and this is the fourth square. So, all the corners are basically placed with the blast holes. So, that is why this is called 4 square, this is called 4 square band cut. So, this 4 square band cut will be practiced in this mine. Reamer hole diameter is kept 91 millimeter. Reamer hole diameter is 91 millimeter. So, there is a mistake here and drilled hole diameters are 38 mm. So, that is not written. So, this 38 drill hole dia with there is a mistake with drill hole dia 38 mm and a reamer hole dia 91 mm. Okay. So, this 91 mm centrally that 91 mm reamer hole and blast holes are drilled with 38 mm. So, this is 38 mm, this is 91 mm. Now, this 91 mm reaming hole is drilled in 3 ways. First this 38 mm is drilled, then that is reamed to 56 mm, then that is finally reamed to 91 mm. So, what is happening here? Basically first a 38 mm drill hole is made, then this 30 hole drill is reamed to 56 mm, then it is finally rimmed to 91 mm. So, the same drill hole is basically drilled thrice. Okay. So, this is taking, as it is drilled thrice, it is taking equivalent to 3 hole drilling time. The drilling time is taken is basically of similar to the drilling of 3 holes. Okay. Drilling length is given 3.2 meter, drilling rate is given 0.5 meter per minute, and the rimming is also considered as the same time, that means 31 to 56, that is also taken, the rimming rate is 0.5 meter per minute, and 56 to 91 rimming rate is also 0.5 meter per minute. Okay. And the detailed design is given, rimming hole is 1, cut hole 16, as it is 4 square burn cut it is given, wall contour holes are 6, that means 3 in this side, 3 in this side, roof contour holes 5, 5 here, lifter holes 5, 5 here, and reserve holes 5, means there is 1 row of reserve hole also available here. Okay. Apart from that, it is also given jumbo drill price is 20 million rupees, that is 2 crore rupees, and fitted with 120 kilowatt motor, that means it is electrically operated, and we have to find out the drilling cost here. So, before doing that, we have to just see what is the jumbo drill. So, let us see in this case, this is a video we have taken from the YouTube. This is a twin boom jumbo. You can see there are 2 boom, one at this place and another is this one. Okay. So, 2 booms are simultaneously carrying out drilling operations, and you can see this is very similar, these arms are very similar, you can see 2 holes are simultaneously being drilled here. So, this is very similar to just like holding a pen in your fingertips. So, the machine is resembled to that, and you can see the 2 holes are drilling simultaneously here. I think this is a better picture, you can see where drilling is carried out. This is one boom, there is another boom here, and how this drill can be carried out at, see, two booms are simultaneously carrying out drilling for the blasting purpose. Okay. So, that is why basically the difference in the other machines and twin boom jumbo is that in the same time 2 drill holes are basically made, and that is why the performance is basically doubled in this case. In fact, historically there are many machines, even 6 boom jumbo, 8 boom jumbos are also possible to have. So, if the drive size is very big like civil sector etc., where very large size excavations tunnels are carried out, 100 square meter tunnel, 50 square meter tunnel. So, their number of drill holes are required are very high. In those cases multiple bumbo jumps are used instead of 1 boom or 2 boom jumbos. Okay. So, let us go for see how to we can calculate this costing. So, we are having total number of blast hole . We are having total number of blast hole 37 and rimmer hole is 1, and this rimmer hole 1 is equivalent to 3 holes because it is drilled once and rimmed 38 to 56 1 and 56 to 91. So, twice rimming, and in our problem we simplified this problem. The rimming time may be different than the drilling time, but for simplification of the problem we have considered the rimming time is also same with the drilling time. So, basically 1 hole of rimmer is equivalent to 3 drill holes. So, now this gives us that we had 37 number but instead of 37 holes we are having 37 plus 3. Actually this reamer hole 1 is equivalent to 3 holes. So, basically we are carrying out drilling of 40 holes. Okay. So, the total drilling, basically this is not drilling plus reaming is carried out for 120 meter times. Okay. So, it is costing to you. So, though you are carrying out a reaming hole, you are carrying out a reaming hole of 91 mm dia and 3.2 meter long, but this is considered equivalent to 38 mm dia of 3 holes, that is 3.2 meter drilling. Okay. So, that is the considerations made here. So, we can consider our total drilling we have carried out is 128 meter, because every time the costing is there. Okay. Now, your drilling rate is given. The drilling rate is given 0.5 meter per minute, but what is happening? We are having 2 boom. So, 2 boom 0.5 plus 0.5. So, simultaneously as it is operating. So, we are basically achieving 0.5 plus 0.5 meter per minute drilling. So, we are achieving 1 meter per minute of drilling. So, considering this, the time required to complete this total 37 holes plus 1 reamer hole, the time required to complete is 128 minute. So, that is 40 into 3.2 divided by 2 into 0.5. So, that gives us 128 minute. Okay. So, that is 32 into 4, that is 128 minute is the time required. So, this is the time required to complete the drilling in that particular phase, and let us see how the holes are being distributed in this phase. Now, it is given to us that 1 reamer hole. So, this is the reamer hole. Okay. Now, there are 4 square holes, cut holes 4 into 4. So, this is so this is 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4. So, these are the 4 square cut, 16 holes. We are having 6 wall contour holes. So, these are the wall contour holes. These are the 6 wall contour holes, and then we are having 5 lifter holes, 5 roof contour holes. So, these are the roof contour holes, and these are the floor contour holes, that is the lifter holes. Okay. These 5 holes. Apart from that, we are having 5 easer holes. These 5 easer holes are placed here. So, if we are having such type of blasting system, I am taking this opportunity to tell you how these delay sequences are provided in this case. So, delay sequences are basically provided, we give the delay for this nearest hole. So, this is the delay number 1 and delay number 1. So, short delay is mentioned in Arabic 1 2 and long delay let us mention in Latin 1 2. Okay. So, in this case we are giving short delay of 1 to this, 2 to this, and then we are giving 3, 3, 3, 3, then or we can again continue the same system 3, 3, 4, 4, then we can have 5, 5, 6, 6, 7, 7, 8, 8. So, after this we can have our long delay. So, this long delay we can provide long delay for this one, that is the long delay 1. Then after that we provide long delay 2 and this is also long delay 2. Then we provide long delay 3 and we can provide long delay 4 here. So, that could be the possible delay sequence. By this way we can progress our blasting for this particular blast pattern. Okay. Now, let us come back into our problem. In this problem we have already drawn the given blast pattern. Now, we check what is the yield from this blast. We have considered that the advance by 3.2 meter drilling, our drilling length is 3.2 meter. We can have an advance of 3 meter. Basically, this is the drive face, this is the drive face, and in this drive face we have carrying out drilling with this is 3.2 meter. But after blasting we did not reach up to this, we have reached our new face is becoming at this position. So, this distance which we have achieved here is 3 meter. So, the face is advanced up to 3 meter. So, next phase of drilling has to be carried out here. So, that is why the advance rate is 3 meter. So, this as the advance rate is 3 meter, the yield will get 3 and the drift size is 4 meter by 5 meter. So, this is 4 by 5. So, this is basically yielding us 60 meter cube of rock. So, 60 meter cube of rock we will get by blasting this 37 holes plus 1 reamer holes of 91 mm, and now we have to find out the cost of this. Okay. Now, if you look into the cost, see we have to consider the life. We have considered the life of the jumbo drill machine is 20,000 hours, scrap value is 0. So, the capital cost is price is given 2 crore rupees, that is the 20 million rupees. So, 20 million minus 0 by 20,000. So, it is 1000 rupees per hour we are getting. Okay. So, cost of drilling phase is that we are expressing it in terms of rupees per meter cube. Say our yield is 60 meter cube. and our for getting this 60 meter cube yield, our drill machine engagement is of 128 minute. We have already calculated this in the previous slide, considering the one drimming hole is equivalent to 3 drilled hole. So, that is why 3 blast hole, that is why this yield is 60 meter cube we obtained from the engagement of 128 minute of the machine. So, our capital cost is rupees per hour, we have to convert it into the rupees per meter cube. Okay. So, to convert it into the rupees per meter cube, we have to multiply it with 128. So, that will give the engagement for one phase. So, this 1000 rupees into 128, that is the cost for one phase, blast, and in this one phase blast we will get 60 meter cube. So, this is basically giving us rupees 2133 rupees 33 paisa per meter cube. Okay. So, the capital cost of this is actually minute, there is a little bit problem. So, this is rupees per hour. So, this is rupees per hour. So, this is 128 minute and this is 60 minute. So, now this is the cost of engagement of one phase of blast. Okay. So, and one phase of blast we engage we get 60 meter cube of material. So, this 60 meter cube of material gives us the capital cost of 35 rupees 55 paisa. Okay. So, that is the costing we have here. So, this is the capital cost. This is the capital cost of the jumbo drill for carrying out drilling in underground phase. Now, maintenance cost we consider it is 10% of the capital cost, because the machine operated is electrically. So, we consider that electrically operated machines having maintenance cost of 10% of capital cost. Okay. So, considering this we have calculated it. So, as it is 10%, so it is 3 rupees 55 paisa, which we have added in the maintenance cost. Now, let us calculate for the operating cost. In operating cost you can see the motor power which is fitted with the jumbo drill is 120 kilowatt, and it is average that power rate is 15 rupees per kilowatt hour. So, in 1 hour the power cost is coming 120 rupees into 15, that is the rupees of power, and 60 is the meter cube we get from one phase, and 128 minute is the requirement of engagement of this one. We convert that in a into the hour by dividing it into the 60. So, 120 kilowatt basically running from approximate for 2 hours etcetera. That price is 120 into 128 by 60, that is the kilowatt hour consumption, that price is 15 rupees. So, that is considered here, and from one phase we are getting 60 meter cube of material. So, this is coming around 64 rupees per meter cube. Okay. So, that is 64 rupees per meter cube is the power cost coming for this coming for this jumbo drill operations. Now, let us consider about the consumables. Consumable is the drill rod we have considered here, and the drill rod price is considered as the 6,000 rupees per piece, and each rod let us consider giving us 1000 meter of drilling. So, it is directly coming for rupees per meter. So, this is 6,000 by 1000 meter. Every phase we have to carry out a drilling of 128 meter. We have seen drilling is carried out, that is 37 into 3.2 plus 3 into 3.2. So, this is the meter, 37 blast holes of 3.2 meter. So, this is actually meter, not minute, and and this is meter cube, and 3, that is the one drimming hole 3.2 meter, 3 times we are considering it is. So, this is coming 128 meter. So, this is 6,000 rupees, 10,000 meter. The total meter we are carrying out drilling 128 meter. By drilling 128 meter, our yield is coming 60 meter cube. So, we are considering here 128 meter and 60 meter cube. So, calculating this, it is coming 12.8 rupees per meter cube is the bit cost coming to this calculation. Now, let us see the manpower cost. Again we have to assume the manpower requirement. We are considering one operator, one helper. So, that there are person requirement 2 persons, and we also consider as 128 minute is required to carry out drilling in one phase. We are considering in one shift one drill group, that is one jumbo drill, one operator and one helper can serve 2 phase. So, similar 2 blast phase can be drilled by one jumbo drill. So, we are considering in one shift 2 blast rounds are made. We have considered the EMS is 4,000 rupees. So, 2 person per shift costing is 8,000 rupees, and we are carrying out blasting in 2 places. So, 2 into 60 meter cube in each phase we have obtained. So, considering that, we have found that 66 rupees per meter cube is the costing coming as the manpower cost. So, 2 person 4,000 rupees per shift. So, that is 8,000 rupees per shift is the manpower cost, and in one shift 2 blast phases are made. So, that is 60 meter cube plus 60 meter cube, 120 meter cube. So, by dividing this, we are getting 66 rupees 66 paisa as the manpower cost for this particular case. Now, similarly, we have considered the overhead cost. So, overhead cost is the 10% of the all other cost. So, it is coming 10% of 182 rupees 50 paisa. So, that is closely coming to 18.25 rupees. So, this is coming around 200 rupees per meter cube is the cost of drilling comes here. Again, if it is considered as the contractual operations, we have to give some profit margin to them, that may be 10%, 15% profit margin can be given to the contractor for its particular profit here. So, other cost component parts like in capital we have not considered interest, we have not considered depreciation. Similarly, in maintenance also we have not considered, many consumables may be there, we have not considered that one. There are some critical conditions may arise in case of jumbo drill. Often you will find out that jumbo drill, the drilling is basically carried out with electrical motor, but often the propelling is made by the diesel engine. So, jumbo drill may have the provision of diesel and electrical double power system. So, if the double power system is coming is considered, in that case double power system is considered, in that case that cost analysis in the for both the power type must be considered in the cost analysis. So, that is one part which is not considered here, but the participant of this course must be very careful when where the accurate analysis is required. Okay. So, I think this is the cost calculation considered for the underground blasting case, where the drilling is carried out by the multi boom jumbos. There may be 2 boom jumbos, 3 boom jumbos. If the jumbos having the multiple boom, you have to consider the number of booms while you are considering the drilling rate. So, drilling rate of 1 boom is given. So, you have to multiply it with the number of booms to get the performance of the machine per hour basis. Then you calculate the cost in hour basis, convert that into the convert that into the meter cube or meter, whatever it is, okay, the requirement is. So, let us stop here for this lecture. We will continue with this blast costing in the next class. Thank you.